Hello everyone, my name is Ishan Sharma. Today we are going to do something cool, predicting loans in India using simple maths. Imagine telling a computer to learn who gets a loan or not. Stick around and we will make it super easy to understand. Let us have some fun with data and numbers together. So let's go. So this is a loan prediction project in which I'll be using logistic regression. It's a machine learning algorithm. So first of all, I have imported these libraries, NumPy. First of all, NumPy, it stands for numerical Python, and it is a library used for numerical operations. After that, it is Pandas. Pandas is a Python library for data manipulation and analysis. Then Seaborn. Seaborn is a data visualization library based on Matplotlib. It provides a high level interface for drawing attractive and informative statistical graphs. Okay. Then this import train test split. This we use to split the data, like 100% data into, let's say, 80% train split and 20% test split. Then this SVM, support vector machine, it's a machine learning algorithm used for classification and regression tasks. Okay. And then this accuracy score, after predicting, we will get that accuracy score, and this accuracy underscore will be used for that. So first of all, we are loading the dataset. It is a CSV file whose name is dataset. Okay. So in this load underscore dataset variable, we are storing this CSV file. Then using this loan underscore dataset, we are seeing the data. So as you can see, it has uh, column names like loan ID, gender, married, dependents, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, and loan status. Okay. Now we are checking the type of it. So it's a data frame. Okay. After that, using this loan underscore dataset dot head command, uh, we will see the five rows of the dataset. Now we will see the number of rows and columns this dataset has. So it has 614 rows and 13 columns. Then using this load underscore dataset dot describe open bracket command, we will find out the mean, standard deviation, uh, total entries, minimum value, uh, first quartile, second quartile, third quartile, and the maximum value. Okay, minimum value is simple, like what is the minimum applicant income. Okay, standard deviation is amount of deviation in each feature, like in applicant income, in co-applicant income. Okay, and etc. And this 25% means uh, like 2877 is there, so 25% of the data is less than this 2877, 50% of the data is less than this 3812, and similarly 75% data is less than 5795, and the maximum value is this 81,000. Okay. And this data is in dollars. Okay. Yes. So we have to drop the missing values, like in the data. If from the CSV file we can see in this data, uh, there are places where there are missing values, like there are 13 places where there is gender not mentioned, or 3 places where married or unmarried is not mentioned. Similarly, dependents and other things are mentioned. So here we will drop the missing values. We can do other things as well, like we can use mean median mode, and we can replace those missing values with the mean median mode. For example, in a categorical type, let's say in a column there are categorical information, so we can replace the missing values by mod. Okay. Also we can use mean in numerical data. So we have used this command loan underscore dataset is equals to loan underscore dataset dot drop na to drop all of these missing values. Okay. Now we will see whether there are any missing values or not. So using this command load underscore dataset dot is null dot sum, we can easily see that there are no missing values anywhere. Now we will do this label encoding. Label encoding means we will change the categorical thing to a numerical one. For example, here in this loan underscore status feature, we will change from n means no to 0 and y means yes to 1. Okay. After that, now we will see the data, the first five rows of it. So here you can see in the loan underscore status that y and n has been changed to 0 and 1. Like here in the features, most of the things are easily understood, like loan id, gender, married. If you, some of you don't know this loan underscore amount underscore term means, it means duration or period for which a loan is taken, specifying the length time over which the borrower will repay the loan. Okay, so it's like that, and it is in days, so it is like 360 days. Okay, 12 months. Now we will see the dependent column values. Okay, dependent means, for example, in a family, let's say a father earns and a father has a wife and two children. Okay, this means that father or that person has three people dependent on him. So there are zero dependents in 274 rows, two dependents in 85 rows, one dependent in 80 rows, and three plus dependents in 41 rows. Okay, so here we are replacing 3 plus to 4 again to make our further calculation easier. We are doing it from 3 plus to 4. Okay, so here with this command load underscore data set dependents dot value underscore counts, we have changed 3 plus to 4. Okay, now we are just visualizing, we are making the plots using this SNS. Okay, it is very useful for if you want to make statistical graphs. So first it is about here x denotes the education, and this loan underscore status, like here it is mentioned. So from the graph you can see like there are a lot of graduated people in the data. You can see from the graph, the people who got the loan and they are graduated are 250 plus, and the people who are graduated who did not get the loan are like 110 or 20, something like that. And the ones who are not graduated on even even they got loan, and they are around 80 plus, and the ones who are not graduated and they did not get loan are around 40 odd. And you can see, like, if you are from the graph, you can see if you are graduated you are more likely to get a loan. Okay, similarly for marital status. Okay, so if you are married, then you will get a loan is like, as per the data, around 250 people got loan who are married, and the ones who are married and did not get loan are around 80 to 90 people. And here the ones who are not married and they got loan are around 100 people, and the ones who are not married and they did not get loan are around 70 people. So here also you can see, if you are married, your chance of getting a loan is higher as per this graph. Okay. Now this gender and loan status. Okay, so if you are male, then uh, like as per the data, 280 male people got loan, and 110 or 120 male people did not get loan, whereas female 70 female got loan, and 40 female did not get loan. So if you are male, again you are highly likely to get a loan approval. Now this is self-employed and loan status. So here x-axis denote self-employed. Okay, so if you are not self-employed, then uh, you are more likely to get loan, because here you can see, as per the data, 280 people who are not self-employed, around 280 people who are not self-employed got loan, and around 125 people who are not self-employed did not get loan. And here uh, around 50 people who are self-employed, they got loan, and around 20-30 people who are self-employed got loan. So again, as per the data, if you are not self-employed, you are more likely to get the loan. So here we are just converting the categorical columns to the numerical columns. Here we are using logistic regression. So it is better if we have things converted into numbers, like binary ones like 1 and 0. So in this loan underscore data, we are replacing, like first in that merit feature, we are replacing no to 0, yes to 1. Similarly in gender, self-employed, property area, rural, semi-urban. Here we are using 0, 1, 2 because there are three answers one can have in that property area. So rural for 0, semi-urban for 1, and urban for 2, and education as well we are changing into binary. For graduate 1, not graduate 0. Okay. Now again we are printing the first five rows. Okay. So here you can see it has loan ID and it is similar to the previous one. Now we are separating the data and the label. So here in the X we are just putting uh, everything except loan underscore ID and loan underscore status. Okay, because this loan underscore ID will not help us in predicting going forward, and this loan underscore status we will put in Y because that's our target variable. Okay, because we will predict that. Okay, so that's why we are splitting it into X and Y. Now first we are printing X. This X has everything except loan ID and loan status, you can see, and that Y has loan status. Okay. Now we are just doing that train test split. So here we chose size is equals to 0.1, which means 90% of the data will be used for training and 10% will be used for test. And this random underscore state is equals to 2 will make sure that we will get same, almost same results. If you will use this random underscore state is equals to 2, you will almost get same result. Whereas if you change this value, then your accuracy may change. After that, we are just printing the number of rows and columns in the X, and here you can see it is 480 rows now, because earlier there were 614 rows. So some of the rows, somewhere around 134 rows has been dropped because those had null values. Okay, and in the test we have 48 rows, and in the train we have 432 rows. Now, from this sklearn.preprocessing, we are importing standard scalar. Standard scalar is a pre-processing technique used in machine learning to standardize or normalize the features of a data set. Standardization involves scaling the feature, which means uh, that the mean is 0 and the standard deviation is 1. Okay, and this ensures that all features contribute equally to the model training and helps in cases where features have different scales. Yeah, and now we are in that scalar variable we have stored that, and this x underscore scaled, we are just fitting the data. By fitting again, it means the same. The mean is 0 and the standard deviation is 1 of the data. And now this x underscore scale, we are just printing it to see how it looks. Okay, it's an array. So it is being standardized. You can see there is not a lot of value. For example, nothing is going towards 5. Okay, the minimum value is like minus 2.42, and the maximum is like 1.25. There can be slightly more maximum value, but the range is not a lot. Okay, now from this stats model dot stats dot outliers underscore influence, we are importing variance underscore inflation underscore factor. Okay, so in that VIF variable we are first storing that our data frame that we have made using pandas, and now we are just checking the values of this various inflation factor. So this basically it is showing the amount of variance in the features, like in the gender, in the merit, independence, and in the so on and so forth, in the property area, the variation. After that, from this sklearn dot linear underscore model library, we are importing this ridge lasso, ridge cv, lasso cv, elastic net, elastic net cv, and logistic regression. These are also regression, like rigid regression, lasso regression. Okay. Now in this log underscore reg variable, we are storing logistic regression, open bracket. And now using this log underscore rig dot fit, this logistic regression, we are just fitting this x train and y train. Okay. And later on we will apply this on the test data to see the accuracy level, to match with it, to match the real and the predicted value. Now in this y underscore pred, we are predicting the y using this x underscore test, and in the prediction we are using this logistic regression algorithm. So now we will finding the accuracy between the y test, okay, the values we have got, and y pred, the values we got after using the logistic regression. These are real, and this we got after prediction. So you can see the accuracy is 0.833, which is pretty decent. Okay. And now from this sklearn.matrix, we will import accuracy underscore score, confusion underscore matrix, ROC underscore curve, ROC underscore AUC underscore score. So confusion matrix is like in this case it's a 2 cross 2 matrix, you can see. So it has four things like true positive, uh, true negative, false positive, false negative. Okay. And we will use this confusion matrix to find out the F1 score, precision, recall. Okay. And that will basically help us in finding the accuracy of the model. Okay. Now again we are just using this lone underscore data set to see our data. It has now 480 rows and 13 columns. And now this y underscore test dot shape has 48 rows because we chose 90% as trained data and 10% as test data. Now here it comes, like the first row and first column of confusion matrix is true underscore positive. Uh, First row and second column of the confusion matrix is false positive. Second row and first column of confusion matrix is false negative, and second row and second column of confusion matrix is true negative. Okay. Now we will find out the accuracy, and the formula for accuracy is true positive plus true negative divided by the sum of all entries of the confusion matrix, that is true underscore positive plus false underscore positive plus false underscore negative plus true underscore negative. Okay, this tells us the accuracy, like how much accurate is our model. Okay, now this precision. Okay, precision is a measure of the accuracy of positive predictions made by a classification model. It is, as you can see, I have written the formula. It is the ratio of true positive prediction to the total number of positive predictions. A high precision indicates that when the model predicts a positive result, it is likely to be correct. Whereas recall, uh, we can call it sensitivity or true positive rate as well. It is the measure of ability of a classification model to capture all the relevant instances. It is, as I have written, it is the ratio of true positive prediction to the total number of actual positive instances in the data. High recall indicates that the model is good at identifying all the positive instances. Okay, like here it is 0.8. Now the F1 score. F1 score is the harmonic mean of precision and recall. It provides a balance between precision and recall. Formula I have written: 2 into recall into precision divided by recall plus precision. F1 score is particularly useful when you want to find a balance between precision and recall, especially when there is an uneven class distribution. Okay. Now this FPR, TPR. FPR is false positivity rate and TPR is true positivity rate. And here it is kind of a syntax like thresholds is equals to ROC underscore curve, because later on we will be making this ROC curve. Okay, this receiver operating characteristic curve. Okay, so we are importing this matplotlib.py plot as a PLT. It is a library which will be used to make this ROC curve. So here the syntax is like plt dot plot and fpr comma tpr. So from the graph also you can see false positivity rate, like we have labeled it x label. On x-axis it is false positivity rate, on y-axis it is true positivity rate. Okay, and we have given it a title like receiver operating character ROC curve. And apart from that, this orange line, apart from this, this line is a random classifier, and the more this yellow line is towards here, towards this true positivity rate, the perfect our curve is. Here it is somewhere like, here it is like covering 0.77 area, so the test quality you can say is good. Okay, so basically there are like if it is between 0.5 to 0.6 it is unsatisfactory. If it is between 0.6 to 0.7 it is satisfactory. Here it is good because it is between 0.7 to 0.8. Had it been between 0.8 to 0.9 it is very good, and if it is between 0.9 to 1 then it is excellent. Basically it is just perfect. And there is a angle shape elbow here, so it is because the ground truth output is 0 1 and my prediction is also 0 1. It is basically binary, and because of this we are getting a angle shape elbow. If rather I have used the probabilities like ranging between 0 to 1, any values between 0 to 1, then it will be a curved elbow. Okay, yeah. Okay, so guys, that's it. Thanks for being with me on this. Friends, we have just cracked the code on predicting loans using simple math and logistic regression. If you enjoyed this video, give it a thumbs up, subscribe for more such easy to follow data science projects, and hit the bell icon to stay tuned. Any doubts or thoughts, drop them in the comment section down below. I'll be more than happy to help you. Thank you guys. Bye.